Let's have a look at another type of function where you have been asked to evaluate limits. Now, unlike the first method that I discussed, here if I put x equals to 2 in this function, I will get it in 0 by 0 form. Now this 0 by 0 form is called indeterminate form. In a situation such as this, if you get your function at the limit value extending to a in an indeterminate form, it is an indicator that you have to simplify your function in some manner. So here what I can do is I can split the numerator into its factors x plus 2 and x minus 2, keeping the denominator as it is, and in the bracket I'm writing the rule that I have used to split the numerator, which is a square minus b square is equal to a plus b into a minus b. Now when I do this, as you can see, x minus 2 appears in the numerator and the denominator and it gets cancelled out. So I can simplify my function to limit x tends to 2, x plus 2. Now if I try to put x equals to 2, I will get the function's value as 2 plus 2 is equal to 4. Therefore, limit x tends to 2, x square minus 4 divided by x minus 2 is equal to 4. That is, 4 is the limiting value to which the function is tending towards as my x approaches 2 from the left hand side as well as the right hand side. Remember that the most useful formulas that come handy when you're trying to simplify such functions are a square minus b square is equal to a plus b into a minus b, or factoring a quadratic equation by using middle term factorization. We have already discussed such examples in the class, so I'm not going to repeat that here. What I want to do instead is repeat another type of example. Another type of question rather of evaluating limits. Suppose you have a function such as this, limit x tending towards infinity, 4x square plus 3x plus 7 divided by 2x square plus x minus 16. Now, as you can observe, if you put x equals to infinity in this question, you will get your function as 4 which is in the infinity by infinity form. Similar to 0 by 0, the infinity by infinity form is also called the indeterminate form. And similar to 0 by 0, if you arrive at the infinity by infinity indeterminate form, it means that you have to simplify your function. The easiest way to solve such questions when you have the infinity by infinity form is to take the highest power of x, or the variable, common in both the denominator and the numerator. So over here, as you can see, in both the numerator and the denominator, it is x square that is common. So I'm going to take x square outside, and I'm left with 4 plus 3 by x plus 7 by x square in the brackets. Similarly, in the denominator, I again take x square common, and I'm left with 2 plus 1 by x minus 16 by x square. Cancelling out x square, since it appears in the numerator as well as denominator, I'm left with the function in this form: limit x tending to infinity, 4 plus 3 by x plus 7 by x square, whole divided by 2 plus 1 by x minus 16 by x square. Now, putting x equals to infinity, I get the function as 4 plus 3 by infinity plus 7 by infinity square, which is again infinity, and the denominator I get 2 plus 1 by infinity minus 16 by infinity. Now remember, any number divided by infinity is equal to 0, and so my function becomes 4 plus 0 by 0 divided by 2 plus 0 minus 0, which means my limit is the finite real number 2.